Okay, so right now we're gonna start our webinar, but we're just gonna wait for some more people to join us. I really hope you hear me well. If you do, send a couple of hearts so that I know that you can hear me well. And before we start and all the people join us, I'm gonna just say about the 3 rules we have for our webinars. Rule number 1, the webinar is recorded. So after you see the actual webinar, you will be able to see the recording on YouTube and the link will be sent to you. Rule number 2, you will be muted during the whole time of the webinar, and if you have any questions, you just have the box in your webinar room where you can ask them. Rule number 3 is not actually a rule, but we will be very happy if you subscribe to our social media after you listen to the webinar. Some more people are joining us. We'll just wait 1 minute, maybe 2. There are a lot of them. Okay. Yeah, I'll just introduce Vadim real quick. Vadim is co-founder of a great company called Vision Arcanum. He works on a great project which helps to convert hand-drawn chemical structures into computer-supported format. Actually, I've shown this app to some of my friends, and every single person out of them said, wow, this is so cool. I really want to have something like that. When I was a student, that would definitely help me in my schoolwork. So yeah, let's invite Vadim to speak, and after that, I'm gonna continue on everything I wanted to say in the beginning.
Thank you, Anna, for the introduction. Hello, everyone, and thank you for joining. I want to show you today what we are building for drawing of chemical structures. But first, I just wanted to give a small introduction. It's not surprising at all that there are 2 completely different ways to draw chemical structures, using pen and paper or using computer mouse. And it's pretty much like writing a piece of text by hand on paper and typing characters on a keyboard. But there is a big difference here, because if you do want to draw on a digital screen, today you can definitely do this. You can use a digital pen or even your finger, and you can write some text on a screen of a phone or screen of a tablet, and software will recognize your handwritten text, will convert it into digital characters. So basically, we can say that today computer understands your handwriting. But it's not the case for chemical structures. If you want your structure in a digital form, you just have to use a computer mouse. And at Vision Arcanum, we are working to change this. We are trying to build a technology that would allow computer to understand chemical structures. And let me now share my screen. So I hope you are seeing my screen. This is the this is our web page, and from here I will go to online drawing tool. So here, you can see the online drawing tool, and on top of it, you will see a small disclaimer that say that we may store some structures you draw to improve the accuracy of recognition. So please do not use this tool for any sensitive or confidential data. But if you do want such solution for your private data, we can definitely build one for you. So now I'm going to close this. Here on the left side, you can see an area where you can draw. And on the right-hand side, you can see the area where results appear. And another disclaimer, I'm not a chemist and I don't have background in chemistry, so I had to memorize some structures to show you. So if you see something that doesn't make much sense, please forgive me, but I will start from something simple. Like this. So here you can see on the right, on top, the structure as it is recognized. So this is how the tool perceives your drawing. The coordinates are more or less as they are in a drawing. And this view here, it's basically just to allow you to understand if the result of recognition is correct, or maybe there is some mistake. And on the bottom here, you can see the final structure. It's cleaned up, all the coordinates are fixed, and if you, for instance, if you have some abbreviations in your drawing, then they will be expanded here. And today we can recognize all the basic stuff, so all the common types of bonds and labels of atoms. And let me try something more interesting. So we do recognize bridge bonds, for instance, and on the bottom you can verify that it actually recognizes bridge as a bridge, so as 2 bonds and not as a carbon with 4 bonds. We do recognize charges. When you are drawing, if there is a mistake, if you make a mistake or if there is a recognition mistake, you can use the erasing tool, which is here, and you can just cross the problematic part and just repeat it like this. Also, you can go back and forth, and you can clean the drawing. And here below, you have some instructions. So what else? We also support stereo bonds. And well, and while we're here, I don't know if it makes sense at all, but we do recognize the resonance structure. So how this all works? Basically, behind the scenes, we have a couple of deep learning models. We can legitimately say in our pro materials that we are based on artificial intelligence. So we have a couple of deep learning models, and they are coupled together by some classical computer vision logic. We do have a big data set which we use for training, and we are still collecting more data. So over time, this technology will improve, will get better. The idea is that this technology can be integrated in other applications as a library or via REST API, for instance. And to illustrate this, let me draw something that I know exists. And here, I will use this search for the structure button. When I click this, we send the final structure, the SDF that we got from this structure, and we run search for this structure in PubChem and in Camspace. So you can see that from PubChem we get we pull some properties of this structure, and from Camspace, if I click here, we can go directly to the page of this compound. And I think that after Anna will tell more about this. So going back here, let me draw something else. So I wanted to talk a little bit about about 3 different levels of difficulty of recognition of structures. So the simplest case is to recognize structure like this in the bottom right. So this structure is generated by a piece of software. So everything is well organized. The bonds have the same length and all the angles are equal. So this is the simple case. A structure like this you can take from a PDF, from a paper, and currently there are even open source tools to recognize such structures. For instance, OSRA is the one which is really popular. But then it has problems with hand-drawn structures. And what we have here is what I would call the second level of difficulty, because this drawing is made on a digital screen with a digital pen, which means that when I draw a bond here, the application actually records all of the points at every moment in time. So it has the information about the motion of the pen, and moreover, there is no noise here. So this is the second level of difficulty. And the most difficult case is a structure which is drawn by hand on a piece of paper, which is then scanned or photographed. So this is where we are heading. This is our goal. In fact, our ultimate goal is to be able to recognize any structure and reaction regardless of where it is coming from. So structure like this from PDF, a structure like this from a screen, or actual hand drawing from a piece of paper. But well, we had to start somewhere. So at the moment we are here at the second level. If you want to try this tool for yourself, you can go to our website, which is visionarcanum.com, and here you will find this link to the online drawing tool. It's also currently available as an extension for OneNote if some of you is a OneNote user. And if you want to contact us, probably the best and easiest way is through LinkedIn, or you can write me an email at it's Vadim at visionarcanum.com. And yes, this is basically everything I have for today. So let me stop sharing the screen.
Okay, we're gonna back to go to my screen. I hope you can see it well. For now, yes. We won this technology war. Okay, so we are really happy to collaborate with this amazing project. And right now I'm gonna show how useful can be this tool for searching compounds through Camspace's catalog. To see that, we're gonna switch real quick to a tablet screen and draw some kind of structure like that. Let it be this pretty spiral cycle. Yes, and we're gonna search this structure using InChI molecule. After that, we get to search results, and if you click one of the links, you will be transferred to Camspace website, where you can access not only the information about the compound, but you can also buy it from different suppliers in a few clicks. It's just that simple. And if you're not happy with that, copy the structure to query editor and you will be able to look at all of the compound derivatives using substructure search. Look what we get using the search, just the derivatives of the compounds. And you can do that with literally every single molecule you can think of. Through the search, you can access more than 500,000 in-stock building blocks and reagents from more than 30 suppliers, 6 million in-stock screening compounds, and billions of make-on-demand analogs to the compounds we have in stock. Besides that, if something that you really want we don't have, you can just shoot an email to Camspace and we will be more than happy to help you find any kind of the compound you would like. Besides that, for long-term projects, we propose procurement and sourcing services on FTE basis. To learn more about what Camspace can provide for your research, just visit our website at camspace.com. And if Vadim is okay with that, we're going to proceed to answering questions. So you just have a couple of minutes to ask whatever questions you'd like, and we'll just see what we have. Okay, so Vadim, what are the main problems that you had to deal with, maybe during working on your app?
As with everything based on deep learning, the main problem is the data, basically. So
I think we lost Vadim on that one. I think he will join us in a couple of minutes. See, today, bad weather, bad internet. Cannot do anything about it. We'll just wait a couple of minutes till he connects back. I really hope you liked our today's event. I know it wasn't perfect, but we really tried to do our best. And if you like it, just send us a couple of hearts so we know that it wasn't. Oh, see, oh, this is so sweet. Okay. I'm just gonna contact Vadim real quick so that we can have him back. And then get back to you. Okay, so miracle happened. Vadim is back. You can continue answering the questions you started to answer.
So you didn't hear me?
No, nothing. You just
Okay.
stopped at the very beginning, so you can just continue.
Okay, so yes,
Where you left.
basically, as with everything related to deep learning, the data is the biggest challenge, and the final result is as good as the data you have. So to get the data at a appropriate amount and the quality and to annotate the data was the main challenge. And we are still working on sourcing as much data of good quality as we can. And in the end, we collaborated with the university here in Barcelona to get the, I would say, the most of the data we have. And we still probably will continue collaborating with them to just grow. Also, if we want to support more features like Marcuse structures, for instance, we will need specific data for this. So yeah, it's always about the data.
Here, people are asking to show the email ID again. So probably you can just spell it for them if that's okay with you.
Yes, it's Vadim, VADIM, at visionarcanum.com.
Great, thank you. Are you going to incorporate any other suppliers and searching systems into the program?
It depends. So we do talk to different people, and basically sometimes we got a response that the feature is interesting, but it's not a priority for people. So these talks takes time. So we would be happy to. And in fact, we quite recently we released the REST API for the technology. So now it's much easier for other applications to integrate the technology into their pipelines. So basically, we hope that this will help people to try it, and if they like it, to integrate faster.
A question personally from me. You were talking about the people who are interested in your technology. Are they more related to desktop programs or more the adaptation to tablets and mobile phones?
Tablets, definitely, yes.
Tablets, definitely. Yeah.
Every
Okay.
time we talk with anything related to desktop, people are more interested in the recognition from photos and scans, which is understandable. So even though you have these hybrids between laptops and tablets now, like Microsoft Surface, for instance, it's still the handwriting and hand drawing with the digital pen. It's more for tablets.
Okay, so continuing on tablets from our viewers, are you planning to make a mobile or tablet app using this technology?
We would like to integrate into the existing ones because it's a challenging task in itself to build a quality application for drawing. And people were working on this for years, and we would really love to integrate into a nice tablet app instead of building one ourselves. Although when we are at the point when we can recognize structures from photos, I think, will build at least a prototype application to showcase this, something that you can use on your phone, point your phone on a piece of paper and recognize the structure from it. Yeah, but we see ourselves more as a technology provider than application developer.
That technology would be very, very useful. I'm just sure. Okay. Maybe there will be any more questions from our viewers. Okay. Are there any analogs to this program, maybe not open source ones?
To my knowledge, no. So there are research papers that deal with handwritten structures, but there is no tool available so far. Not open source, not commercial. At least this is the best of my knowledge. But yes, of course, you have Osra and Imago and other tools for the computer-generated structures.
Okay, thank you. The next one. Please describe what advantages does your product have comparing with EPAM's Imago OCR?
Sorry, can you repeat? I missed the...
With EPAM's Imago OCR, I believe this is some kind of program that might have similar...
Yeah, so these are the tools. These are the tools for recognition of generated structures, but I think I missed the beginning of the question.
Please describe what advantages does your product have over this exact tool?
Well, basically, what we offer is not available in these tools. On the other hand, what they offer is not currently supported by our tool. So we are like two separate subsets for the moment. But yeah, our ultimate goal is to support even to support also the computer-generated structures, and then it will be pretty much like Ostra and other tools. Yeah.
Okay. Can you describe the API?
Yes, basically it's just one endpoint. You send your image, well, not image. You send your traces, you know, the coordinates of your digital pen, and you get back SDF file or smiles or whatever you want.
Okay. We'll wait a minute for maybe somebody decides to ask something more. But we really thank you for joining our today's event. I hope you really liked working with Camspace in the first place. And I hope that people who decided to spend their time with us also are satisfied with what they heard. Personally, I really liked what you told us. It was interesting to hear all the background of working with such technology because personally, I've never had a chance to deal with it in the past time. Uh, yeah, they say great tool, thanks for Dune. So people loved
Thank
your
you.
lecture. So we really thank you, and we thank all the people who decided to join us. And of course, you will be able to look at this once again on YouTube after we're all finished. So hope you have a great day and join Camspace and Vision Arcanum if you decide to come to us once again for our upcoming webinars. Thank you.
Thank you.